All right. In this video, I'm going to be talking about the static keyword. Before I begin, I'm going to pop over to Oracle so we can get kind of like a general definition of what the static keyword is. Okay, so this part right here. The static keyword is used to create fields and methods that belong to a class rather than an instance of a class. So it belongs to a class and not any instance of the class. The other bit here that's important is right here. Where is it? Every instance of the class shares a class variable which is in one fixed location in memory. And then, oh, I forgot this right here as well. They are associated with the class rather than with any object. And again, instance of the class is an object of the class. It's the same thing. And so to kind of illustrate that for some people, I made this kind of cheesy diagram, right? So when I think of class, I think of like a blueprint, right? It's got for a dog, you have name, breed, and here num legs. So this is kind of like a UML diagram, and in UML, if it's underlined, it means it's static. So notice that here's the class, the blueprint, and with the blueprint, we can create multiple copies or versions. I mean, the official word is instances of a dog that has different data fields or different information in it. For instance, here, this first dog instance, the name is Fido and the breed is Poodle. This one is Chester, the breed is Pitbull. This one's Snoopy, breed is Beagle, right? And for the static data field, number of legs, it's something that's shared by all the instances, right? So number of legs, assuming it's a healthy, like regular dog, it's gonna have 4 legs, right? And it'd be a waste of memory to copy or save the number 4 in every single instance of a dog that you create, right? Because there's like limitless number of times you can create a dog instance. So instead, if you know that it's going to be shared, just declare it in the class or create it in the class, and all the instances can all reference the number of legs, and if you allow it, all the instances have access to changing that number of legs, which then will change it for everybody else. It's like one shared variable, right? Okay, so let's get into it. So I created 2 separate Java files. I'll show you the folder. So here's my folder. Notice test static and squalor.java are both in the same folder so they can see each other. So now I have them here side by side. Here's my test static class. Here's my squalor class. Now, in my squalor class, I have, let's look over here. I have data fields and I have my methods. And I created one static version and one non-static version of each. So the non-static version of the one variable is just the number 1, right? And the static version is also just 1. And then the non-static method is called return1, and it returns the number 1. And the static version is called static return1, and it also returns 1. So how do we normally access these variables and these methods in the squalor class, or any class for that matter? So I look over here, my test static, I have my main method. In my main method, I'm going to be doing all of my testing. So in order to create or access any of these methods or variables, you have to create an object of this class or an instance of that class. And how do we do that? We start with the class name. I already did it here. So we got the class name and then the reference variable. Like, what are you going to call that version to refer to it? Or what are you going to call that object to refer to it? So I'm calling mine just X. And then equals the assignment operator, and then this statement or expression right here, new squalor, and then which is a class name, and then open and close parentheses, and this is the constructor. Now I don't have my constructor explicitly written here, and if you don't, Java will automatically just make one. It's pretty much just doing this: public squalor, open close parenthesis, and that's it, right? It's just something to create or construct, hence constructor, an object of this class. So now I've created a fresh new squalor object and I've kind of stored it in X, even though it's not really storing, it's just referring, but you get the point, right? So now with my squalor object X, I can now refer to any of these or access any of these methods or fields. So I have 4 print statements here. The first one, x, which is my Squaller object, dot 1, which is going to refer to this guy. And this one is, and the static, non-static is not going to matter if you access it in this way by creating a new object. So if you look at the other ones, x.static1, so it's going to refer to this instance variable. And then for the non-static method, x.return1, and then x.staticReturn1. So all of these should print 1, and they're all print line statements, so it should create a new line. So I should get 4 1s. So I'll go ahead and run this. And look here, we have 4 1s. So they all worked. I was able to access all of them by creating a new Squaller object. So now let's check out the static. Okay, so what makes the static variables and methods unique? Well, the cool thing is you don't need to create an instance of the object in order to access the variables or methods. Now watch here. All you have to do is get the name of the class, which is Squaller dot static1. And here, the static method, same thing. There's the class dot static return 1. Now this should return 1 and 1, and I should be able to access it. And there it is. Now look what happens when I try to access the non-static variable the way I did with the static variable. So I'm just going to go Squaller class name dot 1. And this one, I'll do the same thing. Okay, so now look what happens when I try to access the non-static variables in the static way. I get this error message. Non-static variable 1 cannot be referenced from a static context. Same thing here. Non-static method return 1 cannot be referenced from a static context. So you can't do this. All right, now I'm going to show you a cool example how an instance of a class can change a static variable for every instance. So what does that mean? So Squaller, again, x is equal to, I'm going to create a new Squaller object, and I'm going to create 2 new Squaller objects actually, and call this one y. All right, let's test some stuff out here. So if we say x dot static, static 1. All right, let's clear this, run it. So notice that x dot static 1, so this x Squaller objects static 1 variable has the value 1, right? Which is right there, and it printed right there. Okay. Now I'm going to change static 1, like so. So x dot static 1 is equal to 999. And I can change it to 999 because it is indeed an integer. So now I'm going to print this, or run this, and indeed, look, static 1 for x has changed to 999. Now the static y was untouched, right? We didn't do anything with y. Well, watch what happens when I change this x to a y. All right, so if you notice here, I'm changing the static 1 variable through or via the x Squaller object. But I'm going to print the y, or static 1, through the y Squaller object. Let's run this, and it's still 999. So notice that if you change a static variable from one instance, it changes it for all instances, past, present, or future. I can even come here and say make a new Squaller z object after the fact, after I even change the static 1. So this didn't even exist. This new Squaller object that I'm putting in z didn't even exist until after I changed static 1 to 999. But watch when I put z.static 1 here. And let's clear and I'll run it. 999. So it just universally changes it because, again, static variables and static methods are universally accessible, and it's the same, it's literally the same spot in memory, right? So there's not multiple copies, and this is useful because it saves memory. It's like more memory efficient. All right, the last thing I wanted to show you guys was kind of like a small exception for static methods or fields that are within the same class. So right now I was calling everything from an outside class, right? All the methods and fields from this Scholar class is a different class. But what if I have static method inside the class that I'm calling it from? Is there going to be a difference? And actually there is a slight difference, not a big deal, but it's good for you guys to know. So first thing, how do I access this return to method and the static return? I could do the same thing as I did before. What is the class that these methods are inside? The test static method. So I have to create a test static object, I'll call X, and then is equal to new test static. And now from here I can go system.out.print and then x.return 2. And I'm lazy, so I'm just going to copy and paste this. And then this one is static return 2. So this should run no problem and return 2 2s or print 2 2s. Bam, 2 2. So that's all normal, right? But now what happens when the static stuff comes in, right? So we can do this like we normally did. So again, no object, because we don't need objects for static. And remember how we call just the class name like this, dot static return 2? So this will work. So let's clear it, and this should print just 1 2, because it'll return the 2 here and then print it. So running it, yeah, and it works. So that all runs normal. Now, the exception part. If you're calling a static method from within the same class, you don't even need the class name. You could just say static return 2. And you run it, and sure enough, 2. All right, well, that's it for the static keyword. Hope that was informative. If not, let me know what I could do to improve in the comments below.